Hi everyone, this is Ethan, and I will be your moderator today for today's CIOE Webinar. Firstly, I would like to thank you all for attending our event and be so supportive under the situation of the pandemic. And then I have to say that it's an honor to invite Jerry Lee, the Sales Director of Flyin Optronics, to deliver this presentation about the application of the passive WDM in global 5G communications. This presentation is about 25 minutes. And then we will move on to the Q&A sections, which is about 5 minutes. So please feel free to submit your questions down below the Q&A windows. Okay, then without further ado, please welcome Jerry.
Hello, everyone. Good morning, good afternoon, and good evening to you. Welcome to the CIOE webinar today. My name is Jerry Lee from Flyin Optronics. The topic for my presentation today is the application of passive WDM in global 5G communication. Firstly, let's have a look at the contents. There are totally 6 parts in my presentation. For the first part, we'll have a look at the global 5G status and overview. For the second part, we'll check the typical 5G system parts. And for part 3 and part 4, part 5, we'll have a look at different passive WDMs for different 5G systems in different countries, like for WDM for China, for South Korea, and also for North America. For the last part, we'll have a look at the reliability test, assurance, and our complete facilities. Okay, let's come to the first part, global 5G status and overview. In April 2019, the first 5G network was launched in South Korea. 3 operators, including KT, SKT, and LG Plus in South Korea, made a very good achievement on 5G construction, and then they also set a very good example for the whole world. And at the same time, the average speed of 5G network in South Korea reached up to 400 megabits per second. It is the best in the world until now. And for USA, the USA also launched the 5G commercial networks in 2019, but with very slow development. With the development for 2 or 3 years, the average speed of 5G network in USA is not as good as they expected, holding around 50 megabits per second. And for China is right now it is the biggest market for 5G. China set up 5G network in June 2019, with very high speed development for 3 years. 5G front haul construction in China is looking to be finished in 2022. And that means it will be finished this year. And China is the biggest 5G market all over the world right now, and it is moving to the next step for the middle haul and the back haul construction soon. Let's have a look at the 5G construction in 2021. Here's a table shows the quantity for the operators who invested in 5G in the year 2021. By the end of December 2021, totally 487 operators from 145 countries invested in 5G, compared to the quantity 412 operators by 2020, increased by 18%. This is a very big improvement, I think. And from the data, we can see this is a very good trend for the 5G development, and also we can see the confidence of for 5G investment. Here's the quantity for the operators who invested in 5G. And as for North America, the quantity is 143, takes up to 29%. And for Asia Pacific, the quantity is 108, take up to 22%. And for the other regions like Europe, Middle East, and Africa, the quantity is 236, take up to 49%. And here are some information for the 5G base station built in 2021. More than 2.2 million 5G base stations were built all over the world in 2021. 1.43 million in China accounted for 65% for global 5G market, and 0.2 million in South Korea accounted for 9%, and for the rest, 26% for the other regions. And start from 2021, the construction for 5G of North America entered the scar construction period. The 5G construction in North America will speed up in the next 3 years. By the end of 2025, 2/3 of the end users will be served with 5G. And also 5G networks will be launched gradually in Europe, in Middle East, and also in Africa. Let's have a look at the 5G construction in Europe. For some reasons, 5G development in Europe is far behind the conformed schedule. It will take up to 10 years to finish the 5G deployment in the whole region. This information is from the CEO of Optoelectronic, Nick Reed. The situation is expected to improve as all European operators gradually recover from the impact of COVID-19. And about 90% of the investment from operators will be in 5G. According to the data from GSMA, 145 billion euros will be invested in telecommunication from year 2020 and 2025, and up to 90% will be for 5G. For the second part, let's have a look at a very typical 5G system parts. Before we talk about WDMs, we will have a look at the whole 5G front haul transmission system. For part one, it's called BBU and AAU equipments. In a word, it is a kind of equipment. And for part two, it is about transceivers. We call it active part. And for part three, passive WDM. This is what Flyin focuses on. And for all the information I will share today, it's all about passive WDM products. Before we look at the detailed products, we will introduce two different passive WDM technologies. The first kind is called AWG, Array Waveguide Grating. AWG technology is one of the most important technology for WDM products. It stands for the future of WDM manufacturing. AWG is made with chip, with one input and also up to 96 outputs aligned on both sides. The biggest advantage for AWG is that the channel uniformity is really perfect. And if you need over 16, or maybe if you need over 20 channels, AWG will be the best choice for you because the average cost for every channel will be low, and also the channel uniformity will be very good. The second kind we call it thin film filter. That's a filter type WDM. It is totally different as AWG because AWG is made with chip, but for thin film filter WDM, it is made with single devices. All the different channel devices, we need to splice it together and put it into a module. It takes very competitive cost and low loss. And especially for the reliability test, thin film filter is much better than AWG module, I think, because normally the operating temperature range for the thin film filter is -40 to 85 degrees centigrade. It is very suitable for an outdoor installation and for the environment. If you need less than 20 channels, I think thin film filter will be a very good choice for you, considering about the cost. Okay, let's have a look at a brief summary for the passive WDM filters 5G system. For passive WDMs, there are different kinds of WDMs made with different filters. But for 5G system, normally we use this 1, 2, 3, 4. We use the 5 different kinds of filters. For the first 3 different kinds, including CWDM, MWDM, and LWDM. These 3 kinds of WDM are all for China market, or China 5G market. For CWDM, the channel spacing is 20 nanometers, and typically there are 2 kinds of modules. The first one is 6-channel CWDM module, and the second one is 12-channel. This is the most widely used 5G WDM modules. Because of the low cost, and this CWDM module is widely used in the China Mobile, China Union, and also China Telecom 5G systems. As for MWDM, it is special designed for China Mobile only. The cost is a little bit higher than CWDM, and we call it is just a common cost. But the 12 channels are special. The cost is a little bit higher, and this product is special for China Mobile only. And for non-WDM, the channel spacing is only 4 nanometers. And this filter is really special for us because we have never made it before. And this product is also only for China Telecom 5G. As for the DWDM, there are two kinds. The first kind is the common one, 100 gigahertz in C-band, around 1550 nanometer. And we can make it up to 40 channels for the 5G. This kind of WDM for 5G system is normally used in LGU+ projects and also for the 5G in North America. As for 150 gigahertz O-band DWDM, this one is special for SKT 5G projects. The special these channels are special designs and also only for SKT, and it's not used for any other operators. Okay, let's come to the third part of WDM, the presentation, passive WDM for 5G system in China. Let's have a look at these two pictures. These are two very typical solutions for the WDM system, for the front-haul transmission system. The first one stands for the 6-channel CWDM system, and the second one is for 12-channel CWDM system. And you can have a look. The operating temperature range for these modules are all -20 to 75 degrees centigrade. And all these modules are taking ABS plastic package. That means the cost is very low because 5G takes very high quantity for all products. So cost is really important for the mass production. Here's a spec for the 6-channel CWDM module, and we don't talk too much about the spec here. If you are interested, you can check it. There's spec for 12-channel CWDM modules. As for the MWDM and for LWDM, the filters inside is different, but the production process and also the package for these modules are almost the same as the CWDM modules. The operating temperature range is also -20 to 75 degrees centigrade and also takes the same box as CWDM. Let's come to the first part, passive WDM for 5G system in Korea. As you know, there are 3 operators in South Korea, KT, SKT, and LG+, but we don't have much experience with KT. So here we only introduce the products for SKT and LG+. Let's have a look at the wavelengths selected by SKT 5G system. Typically, it is 150 gigahertz O-band DWDM module with 17 channels. The most commonly used module is the 1219 CWDM range. And we also have the other, we have a few other CWDM range filters for the design, but it is not widely used yet. I think it's only for future system upgrading. For the WDM for SKT, basically we made 3 different kinds of WDM for them. The first one we call it SMUX, made with AWG. The second kind we call it SMUX, made with thin film filter. And for the third kind we call it CMUX and LMUX. For CMUX and LMUX, it takes the same design, only the inside structure and filters are different, but the package is almost the same. For the AWG module, you can see the operating temperature range is -5 to 65 degrees centigrade. That means it can be used in the central office. It cannot be used outside. And for SMUX with thin film filter, the operating temperature range is -30 to 70 degrees centigrade. That means it can be built outside. And for CMUX, it takes the same operating temperature range as SMUX. Only the design for the box is a little bit different. And for the channels, it's almost the same as SMUX. Let's go to the detailed information for different modules. Here's the information for the AWG. The AWG is packed in ABS plastic box. And here's the spec for it. The most important point is that we need to pay attention. The operating temperature ranges for this module is only -5 to 65 degrees. It's not so wide, so it cannot be used outside. As for SMUX, made with thin film filters, it takes 150 gigahertz O-band DWDM thin film filter, and that's extension port for 5G signal for the whole network. And there's also a monitoring port. The most important, it is packed in aluminum metal case. That means the cost for these two modules will be very high because the cost for the metal case will be much higher than the ABS box. So let's have a look at design for this module. We can know everything with the filter sketch and also with the product spec here. This spec is for the COT module. And here's the spec for the RM module. And here's a very interesting point. There's a mirror built inside this module. This mirror is used for the monitoring port. When you have a signal input from a common port, and it will get to the mirror and be reflected back to the common port. Then you can test if the whole system is working well or not. Let's come to the details for the CMUX module. For CMUX, I think the biggest difference for CMUX and SMUX is about the package. You can see the CMUX modules are designed with two separated modules. The first one is the basic module, and the second one is extension module. That means at the very beginning of the network installation, if you don't need so many channels, you can only choose the 9-channel basic module. And if you have further need in the future, you can have the extension module to put it together with basic module. And for the channel plan, it is almost the same as SMUX. And also you have a monitoring port. It had an extension port for 4G signals. And also the temperature range is also -30 to 70. And but it takes ABS box. ABS box is made by injection mold. The cost is much, much lower than metal case if you have a big quantity. Here's the spec and the design for the SMUX basic module. And here's the spec for the extension module. Okay, let's come to the LMUX. LMUX takes the same package and design as CMUX. It's the same box. It's the same box, it's the same operating temperature range, but the inside structure is totally different. For CMUX, for CMUX basic module, it takes a 9-channel CWDM with one extension port. And for the extension module, it takes 100 gigahertz common DWDM channels. That's the biggest difference from CMUX. For CMUX, it takes 150 gigahertz O-band DWDM. And for LMUX, the extension module takes 100 gigahertz C-band common DWDM channels. Okay, let's come to the WDM for LGU plus 5G systems. Generally speaking, the WDM module for LGU plus takes the same package as SMUX because all these modules are made with ABS box. That means no cost with big quantity. And also the module designed with an extension port for 4G network and also with an OTDR port and with monitoring port. The working temperature range is -30 to 85 degrees centigrade. Okay, here's a spec for the LGU 5G system COT module. You can see the filter sketch, and also you can have a look at the product spec. Here's a spec for the RT module. Okay, let's come to the fifth part of the presentation, the passive WDM for 5G system in North America. I think this part is very important because the WDM system in North America will be a very good example for European 5G projects. As my understanding, I think if Europe will take the same design as North America for 5G passive WDMs. Firstly, let's have a look at the whole system. Here are 3 different parts for the whole system. The first part we call a central office, and it takes mobility installation. That means it can be built inside the central office, or maybe it can be built outside. But normally it will be indoor installation. So that means the operating temperature range for this module will be not so critical. And then we can take a 40-channel Gaussian AWG module. For the 40-channel Gaussian AWG module, the typical advantages is that the insertion loss is very, very low. But the working temperature range is only -5 to 65 degrees centigrade. This is a very typical working temperature range for all the AWG modules. And for the second part, CSP, it takes well-line installation. That means it should be outside. It should be put outside, and the working temperature range for this module will be -40 to 85 degrees centigrade to meet the very critical environment conditions. And for the third part, it will be at the cell site, at the antenna site. They take 5 different kinds of 8-channel DWDM modules. It takes 100 gigahertz C-band DWDM channels. Okay, let's have a look at detailed package for the 3 different kinds of products. The first one is a 40-channel optimal AWG. It is put at the BBU site in the central office. So the condition is very good. They don't need a very critical operating temperature range. So it only takes -5 to 65 degrees centigrade as the operating temperature range. And for the second part, for 5-channel band filter module, it should be put outside. So the operating temperature range is -40 to 85 degrees centigrade. And there will be 5 channels, 5 band filter channels inside one module. It is typical 8-skip 0 filters packed inside. And you can see the picture. This module will be packed inside a terminal box and put outside. For the third part, regarding the 8-channel DWDM module at the cell site, it takes mobility installation. So that means it can be put indoor or maybe outdoor. So to make this requirement, we have to make the module with the operating temperature range like -40 to 85 degrees centigrade. It can be put inside LGMS box or maybe in an enclosure to be outside. Here's a spec for a 40-channel thermal AWG module. Let's have a look at it. It's put inside an LGX box, and then we fit 16 pieces LGX modules in a 5U 90-inch rack mount. Here's a spec for a 5-channel band filter module for the whole system. You can see it from a picture from inside structure. Here's a spec for the 8-channel DWDM modules at the cell site. You can see the picture. Here are 2 kinds of different packages. The first one is for indoor installation, and second one, the black one, it is a kind of a enclosure box. So it should be for outdoor installation. Okay, let's come to part 6 about the reliability, assurance, and facilities. For WDMs, I think optical parameters is not a problem for all the manufacturers because we have the test condition, we have a tested machine, and we have everything, and we can make a very good optical parameters. But what is the difference from different manufacturers? I think reliability test is one of the most important point you need to pay attention to. Let's have a look at the reliability test conditions first. Generally speaking, we have 4 conditions need to be tested, but you can see the fifth line, high power. High power is an additional test condition we have at Flyin only. This is not included in the Telecordia GR standard. And for the reliability test, normally we take Telecordia GR 1221 core standard as our testing standard. So let's have a look at the details. First line is about high temperature storage. This is a dry heat. That means the temperature is 85 degrees centigrade. We don't define the humidity. This takes up to 2,000 hours for test. And the second one is high temperature storage, but damp heat. That means the temperature is 85 degrees centigrade and the humidity is 85%. And it also takes 2,000 hours for test. And the third one is a low temperature storage. The temperature is -40 degrees centigrade, and we have to put everything inside for 2,000 hours. The last one is for temperature cycling. And the temperature range is from -40 to 85 degrees centigrade, and the test takes about 500 hours. And last one is high power. High power is special designed for the 5G products, because for 5G system, sometimes the power for the whole system is really high. To avoid any problems caused by high power, we need to test the WDM devices with high power before we send to our customers. And you can have a look about our pictures for all the facilities and equipments. The equipments for dump heat, test equipments, and also temperature cycling, and also for high low temperature storage, and also for high power test. Besides that, we also have some other reliability tests during our production. A PCT test. PCT test is very common for us because we need to know the quality level of our products during our production. For PCT test, it takes only 168 hours only. So that means we can do it very often. So let's have a look at the condition for the PCT test. The temperature is 110 degrees centigrade. The humidity is 100% humidity. And also the pressure is very high. It's 1.2 bars. It takes 168 hours for the whole test. And also for all the WDM single devices, we also need to have an agent test before we do the assembly. And the agent test, it is also a kind of a temperature cycling. That means the temperature is from -40 to 85 degrees centigrade. And we also set it up for test with 48 hours, 6 hours a circle, and totally we have to take 8 circles. And for all the WDM devices, it need to pass this test before we put into the modules. For the reliability test, it only be done for new products and for new production processes. For PCT test, it will be done to know products reliability with our mass production. For 48-hour temperature cycling, it will be done for every single devices we produce. Okay, here are some pictures of our office and the production line and the engineering. Have a look at it. Here's a machine for the thin film filter design and coating, and also our test position for the WDM devices and modules. And also here's our WDM testing system. Okay, I think I have fixed everything, and if you have any questions, please submit your questions at the Q&A section, and I will try to answer later. Thank you very much.
Hi, everyone. Sorry to drag a little bit longer because we got a problem during streaming the Zoom. So genuinely, I hope you can understand. And thank you so much, Jerry, for your insights. And we have a few questions right here, and hope you can share your ideas about it. Okay. So the first one is that, are there any new technologies for the passive WDM product, whether in design or production? What do you think?
New technology for WDM, yes, sure. Of course, there are new technologies for WDM design and production. And like the AWG technology, it is also a very good example. With so many years development, AWG technology have already been widely used in many different areas, including the AWG for long distance WDM transmission system, AWG for the 5G systems, and also the AWG 4-channel for high-speed transceivers. Basically, AWG technology is always developing, and it will be used more and more widely in the future. And the second new technology I need to mention is kind of free space technology. The free space technology has already been widely used in the CWDM and the DWDM products design. And normally we call it compact CWDM and the compact DWDM. The free space WDM takes much smaller product package than the common products, but at the same time, it takes the same product reliability and even better optical parameters. Such compact WDM products can be used in solutions which there's a very limited space for the product integrations. That's all. Thank you very much.
Okay, thank you. And so we're running a little late, so that next question will be our final question. Okay. So in your opinion, what will be the next big market for 5G projects?
European? Yes, I agree. I agree with this opinion. As I talked in the presentation, the 5G construction is hot all over the world right now, and especially in North America. The 5G construction is ongoing, and the trend of development will be increasing for the next 3 years until 2025. So I think there might be market and chances in North America, and at the same time, I think there will be more chances and market in Europe for the next 5 years, because the development of 5G Europe is behind the schedule, and also the operators are looking to invest in 5G to catch up with the schedule. So for the next 5 years, we are looking forward to the good development of 5G in Europe, and at the same time, for the other regions, I think the Middle East and Africa will be also a good market for 5G systems and construction. That's only my opinion and only for your reference. Thank you very much.
Thank you. Thank you for sharing. I can see there's a bright future ahead of us. Okay. Okay. And I guess for our audience, thank you so much for participating in today's webinar, and I hope you have all the information you need today. Okay.
Okay.
And yeah, let's move to the final parts. Yeah, a kind of reminder that the 24th China International Optoelectronics exhibition will be held at this September 7th to 9th at Shenzhen World Exhibition and Convention Center. You can easily register for the CIOE 2022 by scanning the QR code and fill out the information. I hope we can have you all to our extraordinary event this year. Take care and see you next time. Goodbye.
Goodbye, everyone. Thank you.
Thank you.